Okay, today we're going to go over the direct comparison test, which is just a way to find the convergence or divergence of an infinite series. Now, I should preface this lesson by saying I will refer to a series that diverges as a divergent and a series that converges as a convergent. So keep that in mind. Now, let's go ahead and look at this. It may look a bit complicated, but all this is saying is that B sub n, which is an alteration of A sub n, meaning B sub n can either be greater or less than A sub n. If the series of B sub n converges and B sub n is greater than A sub n, then the series of A sub n will converge as well. And it also states that the series of B sub n, if it happens to diverge and it happens to be less than A sub n, then the series of A sub n diverges as well. Now, if A sub n is less than B sub n and the series of B sub n diverges, then the test comes back inconclusive and vice versa as well. You can memorize this by remembering the following phrases. Less than a divergent diverges, sorry, greater than a divergent diverges, and less than a convergent converges. So what does this mean? It's saying less than a divergent, sorry, greater than a divergent diverges. So A sub n, if A sub n happens to be greater than B sub n, and B sub n is a divergent, meaning it diverges, then the series of A sub n diverges as well. And it also states that from the less than the convergent converges, states that if A sub n is less than B sub n, and B sub n is a convergent, meaning B sub n, meaning the series of B sub n converges, then the series of A sub n converges as well. So remember that greater than a divergent diverges, less than a convergent converges. Okay, let's go over example problem 1. You may notice that this is a little difficult to compute, or sorry, find the convergence or divergence of. So we're going to try to compare it to a different series. Let's start off by getting rid of the 2. So we're going to compare it, and you must state this to, let's say, your series from n equals 1 to infinity. Let's get rid of the 2, like I said earlier. It's going to make it easier on ourselves. And since we are essentially adding to, since we're adding to the denominator, we are lowering the function. So this is greater than this. This series is greater, or sorry, this function is greater than this function. Now let's make this a bit easier on the eyes. We're going to change 3 to the power of 1 over 3 to the power of negative n to 3 to the power of n, because you'll remember that you can switch variables from the denominator to the numerator or vice versa by changing the sign of the exponent. So, and keep in mind that this is less than this. Now we can employ the GeoTerms test. We're going to say the absolute value of r is equal to 3. And since it's greater than 1, we know that this series here diverges. So you can put this series from n equals 1 to infinity of, well, actually, we can't state that yet. We have to state that 1 over 3 to the power of negative n minus 2. We know that this is greater than 3 to the power of n. Now, since we have, let's say A sub n, let's call this A sub n. Since A sub n is greater than B sub n, and since B sub n diverges, we know that this diverges because we can remember the phrase greater than a divergent diverges. So we can state that the series from n equals 1 to infinity of 1 over 3 to the power of negative n minus 2, we can state that this diverges by direct comparison test. All right, this is example problem 2. We're going to compare this. Let's get rid of the 1. You're usually going to want to get rid of any like real number. let's compare this to the series n equals 1 to infinity of, let's say n, like I said, let's get rid of the 1. So let's say n over n to the power of 3. Now, of course, this can be simplified to 1 over the power 1 over n squared. Now we can employ the p-series test. We can say that p is equal to 2. And as you know, 2 is greater than 1. And so this series over here converges. So now we have to compare the functions to see which one is greater or less than. So n over n cubed plus 1 compared to n squared. This is less than this. And the reason is we are adding to the denominator, which is going to decrease the overall function. So now we know that, let's say a sub n is less than b sub n, and b sub n converges. So we know the phrase less than a convergent converges. So by that logic, this series converges. So we have to state that series from n equals 1 to infinity of n over n cubed plus 1 converges by the direct comparison test.